Okay, in example 5, we're going to figure out how many Python identifiers there are that are 5 characters in length or less. So that's the reason why I started by breaking down the setup into 5 different groups. Groups of 1 length ID, 2 length, and then 3, 4, and 5 ID. So when I say 5-ID, I'm talking about IDs that are 5 characters long. So, 1, 2, 3, 4, 5. When I'm saying 4 ID, that means 1, 2, 3, 4, and so on and so forth. 1, 2, 3, 1, 2, and then 1. Okay. So I'm going to calculate each one of those separately and then figure out what the total is going to be like. So there are certain restrictions that you have to kind of think about when you're doing this. So the first character has to be always either by itself or followed by additional stuff, but it's always going to be one of 53 symbols, either the upper or lowercase Roman alphabet numerals or the underscore. So if you have one letter ID, there has to be one of 53 choices. Okay. Now if you have 2 of them, the first letter has to be either an underscore, uppercase, or lowercase, so that's again 53. But the second one can be any from the additional 63 symbols, either the 52 upper or lowercase alphabet, the underscore, or the 10 digits. So if you have 2 IDs, then the first one has to be 53 choices, and the second one can come from any of 63 choices. And again, if you have 3 length ID, the first one has to be underscore, uppercase, or lowercase Roman numeral, and the other 2 can be any of the 63 other possible choices. And repeats are allowed, so that's why I'm choosing 63, 63 again. And same thing again for the next 2. So if I add these numbers up together, I'm going to end up with the possible IDs that are less than or equal to 5 characters in length. Okay, so let's go ahead and do that. Let's say roughly 53 billion. Okay, now some of these are not allowed. There are 31 keywords that are not allowed. So what's the answer? Well, since 31 words are not allowed, we're gonna have to take this ridiculously large number and take away the 31 words that are not allowed. So basically use the difference rule. So I just used the additional rule to do this, and now I'm gonna use the difference rule to figure out the total number of Python words in the question. So the number in question here represents about, roughly speaking again, 53 billion, okay? Again, this all works because the grouping that I made up in my rectangle right here, that grouping is all of sets that are disjoint. No one character ID can be mistaken for a 4 character ID or vice versa. So the sets are disjoint. That's the reason why I can separately calculate each one of them, then add up the total to get the whole set. And I had to take away the 31 keywords because those are set aside for special symbols.